ASDIP analysis includes the generation of snow loads per the ASDIP provisions. But what kind of information is required in the program to do this kind of analysis? How do you interpret the results? This is Javier Encinas, and today I will present an example of the generation of snow loads in a roof structure. Let's get started. As an example, consider this roof structure, which is located in a surface roughness category C. The roof is fully exposed. The ground snow load is 25 psf, thermal condition A, risk category 2, and the roof slope is 1/4 inch per foot. In addition, we are required to calculate the snow drift, so the accumulation of snow in certain areas, for example, at the roof step, when the roof step height is 10 feet. At a parapet, the parapet height is 6 feet. At a roof projection, the roof projection height is 7 feet. At an adjacent structure, the height difference between both structures is 18 feet, and the building separation is 12 feet. With this information, we are required to calculate the uniform snow load on the entire roof, and in addition, the snow drift, the accumulation of snow in certain areas as explained here. To do this analysis, we will use ASDIP analysis. Let's go there. When you open ASDIP analysis, you see the modules included in the package: seismic loads, snow loads, wind loads, and beam analysis. Today we're going to generate a snow loads calculation. I have prepared an example already for this purpose. Let's double click on this node. In the ground snow tab, you enter the surface roughness category C. Roof exposure is fully exposed on all sides with no shelter. The ground snow load is 25 psf. All this is information given in the statement of the example. Click on the building tab. The thermal condition is A, heated structures with unventilated roofs. The risk category is 2, and the roof geometry, the roof slope, is 1/4 inch per foot. The eve to reach width is 100 feet. Let's go to the snow drift tab. Here we enter the information given in the statement of the example for the snow drift calculation. For roof step, the step height is 10 feet. At the parapet height is 6 feet. At roof projection height is 10 feet. And at adjacent structure, the height difference between both structures is 18 feet, and the building separation is 12 feet. So all this information is already entered here. At the right-hand side, we have the calculations tab, which includes the step-by-step calculations with exposed formulas and references to the AS7 provision. The program calculates the flat roof snow load, PF, 17.3 psf, then the minimum roof snow load, 25 psf, the balanced flat load as 25.3 psf. For the sloped roof snow load, the program calculates the sloped roof balance condition, 25.3 psf, which corresponds to a balanced snow height of 1.47 feet. And the program provides all the corresponding references to the AS7 provision. For the calculation of snow drift for the first condition at roof step, the program calculates the snow drift for both conditions, windward and leeward. In this case, the program finds the leeward drift controls the design. So the total drift is 5.57 feet, corresponding to a total drift load of 96.1 psf. At parapet condition, the program calculates the windward drift as 3.43 feet, corresponding to a drift height of 3.43 feet. So the total drift is 76.4 psf. At the roof projection, the program calculates the windward drift as 3.43 feet, corresponding to a drift load of 59.1 psf. So the total drift load is 76.4 psf for this condition. Finally, for the condition at adjacent structure, the program calculates the windward drift and the leeward drift, first assuming a separation of 0 and then assuming a separation of 12 feet. Then the program calculates that the maximum drift height is 4.57 feet, corresponding to a total drift load of 96.1 psf. All this complies with the ASDIP 722. Graphically, if we go to the Graph tab, we can see here the 4 conditions for the snow drift calculation: roof step with the height and length, then at the roof parapet, the height and length for the parapet condition, then at the roof projection, the length and height, and finally at the adjacent structure, the condition is this height and this length. As you can see, it's very easy to generate the snow loads in a roof structure using ASDIP analysis. We were able to generate the loads, not only the uniform load on the roof, but also the snow drift calculation for different conditions. All this was done in just a few minutes, which otherwise could take much longer if you try to do it by hand. If you like the software, please visit the website www.asdipsoft.com and download the free 15-day trial. Please subscribe to the channel if you want to receive notifications in the future for similar videos. Thank you for your attention.